My name's Shihab, and I'm the team lead on the integration team at Atlassian. You might remember me from earlier this morning, but what I'm here to talk to you guys about are the cool things that we've been doing with Wallboards. Now, how many of you guys have a wallboard or an information radiator in your office? Yeah, that's quite a few. So these radiators help you effectively communicate the status of your project to both within and outside your team. Things such as build breakages, cumulative flow diagrams, even the number of days left in your iteration can be up for the world to see. Now, we've got information radiators throughout Atlassian, and it's got to the extent where even my product manager comes up to me and starts complaining about the state of our red builds, like it's his own problem. And that's a good thing. Now, back in November last year, we ran a competition to discover which team around the world had the most ultimate wallboard. Now, there are a few categories for prizes last year, including the best old school wallboard and the community favorite. But the one that caught my eye actually happened to be the Ultimate Wallboards winner. And that was the Vodafone web team from Copenhagen. Now, if you haven't seen this before, I definitely recommend you guys check out their video online. So what these guys do is they walk up to their wallboard and they drag physical RFID cards on their card wall. And this causes issue transitions in Jira. And the resultant burn down chart is then projected back onto the screen. And when I first saw this just blew my mind. Interactive information radiators using cool bits of technology. Now, around the same time last year, a new piece of tech was opened up thanks to a hacker who happened to be analyzing the USB traffic between the Xbox and the Kinect. Now, how many of you guys have played with the Xbox before? Yeah, a fair few of you actually. So you know those motion-sensitive games such as fighting and dancing? So you probably appreciate that the Xbox is quite an advanced piece of technology. Now, I've got an Xbox set up here with my wallboard. Don't know if you can see it from the back, but basically it's got an IR transmitter and receiver pair. So I'll just point to it on the screen. It's got a standard webcam, and the webcam is no more powerful than the camera on your iPhones today. And it's also got the interesting pair of components. Now, these IR transmitter and receiver pairs allow the Kinect to determine the relative depth of pixels in the Kinect's field of view. Now, I'll step back for a bit of revision. Now, you guys know that images are composed of many, many pixels. And each pixel is essentially a color value. Now, what the Kinect gives you for each and every pixel is the relative distance that pixel is away from the Kinect. Now, this depth detection is what sets the Kinect apart. It makes it significantly easier from a computer vision perspective to carve out the image to perform detection and tracking. And I'll get into that in a sec. But all of this tech that was flying around on the internet back in November just immediately spawned a dream. Wouldn't it be cool if you could interact with your wallboard just by waving your hands? So no need to print out QR codes or mess with RFID tags. You just walk up to the wallboard and do your thing. Now, the back of the napkin design, like this is the literal design for this, was with a Kinect hooked up to your wallboard and a user entering some sort of zone of interaction. So when they enter this hot zone, the wallboard becomes interactive so that they can play with it. And once they're done, they step out and the wallboard returns back to its passive cycling manner. Now, if you're following along and if you've done any image analysis before, you can appreciate that at the low level, we're going to be getting zeros and ones from the Kinect. And what we need to try and do is determine where the user's hands are in the stream of zeros and ones. Now, at a slightly higher level, we need to try and work out what the user is trying to do. Are they trying to select something, grab, flick, or perhaps do nothing at all? Now, the rough architecture of our system is on the screen. We've got a computer vision process that churns through the Kinect output. Now, this process is written in C and C++. What that does is it determines, has the user approached the wallboard? Have they walked away? Where are they pointing at? Now, it passes this information on using mouse movements and keyboard signals. So basically, the computer vision process emulates operating system input. And that's how we get the input from the Kinect to the web browser. So our UI is still the standard Jira Wallboards view. And in our Wallboard, we have a Jira plugin, which is no more than a few REST resources and web resources, which capture the JavaScript events, so the key press and mouse move events, and then take action upon it. So basically, we update Jira and GreenHopper. Well, that's enough talk. I'm here to demo how it's working behind the scenes. You guys have seen it working up at the keynote. So hopefully this will give you an insight into what's going on in the background. Just bear with me while I switch to my Wallboard. You go. So as you guys can see, there's 4 viewports there. And this is basically what's going on inside the computer vision process. Now I'll go through each of these viewports and I'll try and explain what's going on. Now, if you look at the top left quadrant, that's the color image from the Kinect. It's pretty dark over there because there's not that much light on me at the moment. But we don't really use this image on the top left for any computer vision purposes. We've only got it there to visualize the output. Now if you look at the bottom left quadrant over here, here's where it starts to get interesting. Now how many of you guys have seen the movie Predator? Yeah. Well, unfortunately this is nothing like it. So what I've done here is I've encoded the depth information from the Kinect and I've encoded it to colors. So the near pixels are colored in the warmer shades, and as I move further and further away, the colors transition into the hues of green and blue. Now what can we do with this depth information? If you look at the bottom right quadrant over here, you can see that I've set all of the pixels to be off, so it's pitch black. Now watch what happens as I walk towards the Kinect. You can see that there's this imaginary plane right here that I've intersected with. And if I'm nearer to the Kinect than this plane, the pixels light up. And if I'm further away, the pixels are off. So we've got our zone of interaction defined right there. And then now the computer vision process can fire a Control-Shift-1 for user enter and a Control-Shift-2 for user exit. So we can pass on this information to the UI. Now what about detecting where the user's actually pointing? Well, it turns out you can use a similar approach to work out where the user's palm is. So I've got another plane here, which is the hand plane. And as you can see on the top right quadrant, my hand is being masked out. If you look at the top left quadrant, I'm tracking the center of my palm using a green dot. So that's where the computer vision process thinks I'm pointing at. Now it's very easy to transform the coordinates of this green dot into the coordinates of the screen space. So we can pass on this information as mouse movements. Now there's one little bit of computer vision information that we need. And that's whether the user's palm is opened or closed, as you saw in the keynote. Now, if you look at my open palm, what do you notice? Yeah, it's roughly a star shape with pointy bits representing my fingers and inverted pointy bits representing the bits between my fingers. Now it turns out if we look for these inverted pointy bits, we can distinguish an open palm from a closed palm. So if you look at the top left quadrant again, you can see that there are blue dots placed. I don't know how well you can see that from the back though. There are blue dots placed between my fingers. And if I close my palm, those blue dots disappear. So that's the computer vision process detecting the bits between my fingers. Now we can use this heuristic to reliably determine if the palm's opened or closed. So we've got quite a few bits of information. We know if the user's present, we know where they're pointing, and we know what their hand is doing. So let's see if we can tie this information back into the UI. Okay, so here I've got my passive wallboard, and it rotates through wall frames every 30 seconds. And you can play around with these demo stations that we've got set up outside. Now watch what happens if I enter that zone of interaction again. Now the wallboard's detected that I'm there, and it's encouraging me to interact. So basically the computer vision process fires that key press, and the UI is responding. Now one of the first things we implemented was Wallboard Swipe. So I can navigate to the wall frame that I'm interested in. And we do this by listening for fast horizontal movements in the UI, so fast mouse movements from left to right or back from right to left. And we also implemented some visual cues to let the user know that their hand is off the edge of the screen or their palm isn't near enough to the screen to register accurate recognition. So basically their palm hasn't intersected with that hand plane. Now, I don't know about you guys. That is not part of the demo. But you probably appreciate that this is one of the most demo-rich talks that we've organized. Now, one of the things that I love about Wallboards, traditional card walls, is the fact that you can physically pick up a card and transition it from in progress to done. And you get that awesome sense of satisfaction. Now that's something we looked at replicating in the digital world. And I'll show you how that works, if it works. So I step up to the wallboard, and rather than swiping through wall frames, I let the taskboard know that I want to interact with it. So we looked at implementing push to click. So I had a chat with some of the people outside, and they were asking, why didn't you implement a button or something like that? We actually tried that and found that it wasn't as reliable as hover to click, so you don't get the same resolution. So you let the system know which user you want to execute the transitions in the context of. And as you can see, my palm is being accurately recognized, so I can single out the card that I want to pick out. So maybe train more stormtroopers. I hover over it and I close my palm. Now what's happening is the computer vision process sends that event. The UI lifts the card out of the DOM, so I'm dragging it. And I can hover over the done column, release, and there you go. So that's the transition. Now what's happening in the background is a REST request is made to Jira to update that issue, and then it transitions to done, and the screen is being re-rendered. Well, ladies and gentlemen, there you have it. Interactive information radiators using cool bits of technology. Now this isn't the end. This is just the beginning, and let me show you why. What I want you guys to do is note down this URL. Yay. We're making the source code available for you today. Now what we'd like you guys to do is go home, take the Kinect away from the kids, and plug it into your wallboard. Now the code itself is in a tech demo state, so as you can see there's a few issues. But what we're hoping to do is when Microsoft release the official SDK for the Kinect, we're hoping to package it up so that it's a browser plugin. But at the moment, you can play around with it and you can install it on your Jira instances. What we're really keen on, though, is the next level of innovation. So perhaps expose for Wallboards. Issue assignment by grabbing an issue and dragging it to an avatar. How about agile estimation just by using your hands? Exactly. Or face recognition for authentication. Now, we think the possibilities for this are endless. So we'd like to invite you, all of you guys, to join us in developing some cool plugins, playing with some awesome tech, and just having loads of fun. Thanks.